Man, I don't know about you guys, but have you noticed a change in the temperature? It's getting so warm. Can I get a fan or some water, please? Thank you. Now that's better. Hi, my STEAM friends. If you haven't guessed already, today we're going to talk about heat, or what scientists like to call thermal energy. Before we explore, let's go over each letter in the word STEAM. If you know it, you can say it with me. STEAM stands for science, technology, engineering, art, and math. Great job! For this unit, we will focus on the S for science, the E for engineering, and the M for math. Now, let's explore. Thermal energy is the energy an object has because of the movement or vibrations of its molecules that causes objects to be hot or cold. Everything on Earth is made up of molecules, including you and me. Molecules are very, very, very small and always moving. The more they get excited, the more they move. So think about it. Try jumping in place. The more excited and faster you jump, the warmer you become. That is because the molecules in your body are moving more and becoming more excited, bumping into other molecules, causing your temperature to rise. Thermal energy is also known as heat energy because heat is the transfer of energy to another object that is lower in temperature. Heat makes molecules get excited, and they transfer that excitement to other molecules to get them excited. The more excited these molecules get, the hotter the object. And all transfer means is to move from one place to another. What ways can you think of that we use heat? You can pause this video and discuss with your class now. So I think of hot food, hot showers, washing your clothes, or a heater. As you can see, like light and sound, thermal energy is another form of energy that helps us in our everyday life. Remember, energy is the ability to do work or how things move and change. When we learned about sound, we learned that the more energy, the more the vibrations, the louder the sound. And the less energy equals the less vibrations and the lower the sound. Thermal energy is similar. Thermal energy is the energy an object has because of the movement or vibrations of its molecules that causes an object to be hot or cold. An example, a cold glass of water or lemonade has energy that moves slow. However, an object like hot boiling water or hot chocolate has energy that moves fast, and the molecules vibrate and collide into each other. As the molecules get hotter, the thermal energy increases. So, slow-moving molecules equal less energy, which equals something cold. Fast-moving molecules equal more energy, which equals something hot. Huh? What was that? How do objects get hot or cold, you ask? Great question. I'm glad you asked. Take some time to pause and discuss how you think objects heat up or cool down. So, how do objects heat up and cool down? Well, thermal energy comes from sources like the sunlight, electricity, and fire. Sunlight is both light and thermal energy. It heats up animals and bodies of water like lakes, rivers, and oceans. Electricity is like your oven or your microwave that uses electricity to produce thermal energy to cook food. And fire is both light and thermal energy. Fire keeps us warm and helps us cook food. Did you know that even cold objects have heat? Yep, that's right. Anything that has molecules produces heat. The molecules in cold objects are just moving slowly. And we know that slow movements equal less energy, which equals a cold object. So let's test this out with a challenge. Today's challenge is to see what objects melt in the sun. So let's begin. For this project, you will need a Lego, a marshmallow, aluminum pan, a timer, a cotton ball, butter, cheese, and some ice. You can also use a broken crayon or a rock or any other supply you think may melt that you have at school. And you'll also need what melts in the sun data sheet, just like a real scientist. So, the instructions are to take out all the items listed, and you'll place them in your aluminum pan. With your cheese, you can break this in half. You'll look at each of your items and think about what they are and if they will melt. On your data sheet, in the will it melt column, you will make a guess about what item will melt in the sun. So on the first one, it says Lego. If you think it will melt in the sun, you would circle the thumbs up. If you don't think it will melt in the sun, you will circle the thumbs down. Once you have made your guess, take your tray to a sunny area. Set your timer for 15 minutes. After the 15 minutes is over, check your results. Did some of your items melt? Which items melted and which items didn't melt? Were your guesses correct? On your data sheet, in the Did It Melt column, you will mark down what actually happened. Compare your results, and if you thought something would melt that didn't, take time to think about why. If you didn't think something would melt, but it did, think about why and share your guesses with the class. Also think about if anything felt warmer, even if it didn't melt. So STEAM friends, I hope you learned from this challenge how thermal energy works. Remember, thermal energy is the energy an object has because of the movement or vibrations of its molecules that causes an object to be hot or cold. The source of thermal energy that we experienced in today's project was sunlight. The sunlight transferred, which means moved from one place to another, its heat to our objects, causing the items to heat up and some of them to melt. That means our objects that melted had very fast moving molecules. Those molecules produced a lot of energy, which made a super hot or melted object. Remember, thermal energy is the energy an object has because of the movement or vibration of its molecules that cause an object to be hot or cold. Everything on Earth is made up of molecules. Thermal energy is also known as heat energy because heat is the transfer of energy to another object that is lower in temperature. All transfer means is to move from one place to another. And energy is the ability to do work or how things move and change. Thermal energy comes from sources like sunlight, electricity, and fire. Sunlight is light and thermal energy. It heats up animals and bodies of water like lakes, rivers, and oceans. And like we saw today, the sunlight also heated up our objects we set outside. Electricity is like your oven or microwave that uses electricity to produce thermal energy to cook food. And fire is light and thermal energy. Fire keeps us warm and helps us cook food. So think about it. Remember that slow-moving molecules equal less energy, which equals something cold. And fast-moving molecules equal more energy, which equals something hot. What object can you find today that has slow-moving molecules or fast-moving molecules? When you find them, write them down to share when we meet via Zoom. Lastly, don't forget to look over your STEAM career cards, where you can learn more about a climatologist, a zoologist, a physicist, and an energy auditor. Be great, my STEAM friends. Until next time, bye-bye.